Good morning, friends. Today I am going to demonstrate you the ISIS multi-level route propagation in the segment routing. So if we implement the segment routing in the multi-level ISIS scenario, it does not alter the fundamental functioning of the segment routing or ISIS. So the multi-level or multi-area prefixes and their associate prefix segment IDs are still propagated from one area or level to another. However, adjacency-sids remain locals to the individual routers, and those are not propagated across the different area or level. So if we talk about the default ISIS architecture, the level 2 routes are not propagated from the, by default level 2 routes are not propagated from level 2 to level 1 area. The level 1 and level 2 router just set the attach bit towards the level 1 routers, and they generate the default route towards the L1 and L2 routes. So we need to define the propagation policy or route policy to propagate those routes into the level 1 routes. But while doing that, will functioning of the ISIS will be consistent. So if you can see in this topology, the R1, R2 are the level 1 routers, R6 is part of another level 1 routers, R3 is the level 1 route, level 1 and level 2 routes, and R5 is also level 1 level 2 routes. R4 is acting as a level 2 routers. So if we check about the adjacency, so let's check. So R1 has adjacency with the R2, that is the level 1. R2 has ISIS adjacency with the R1 and R2, that is also level 1. R3 is acting as a level 1 and level 2 router, so it has the level 1 adjacency with R2 and then level 2 adjacency with R4. R4 is acting as a level 2 routes, so it has both the adjacency as the level 2 adjacencies. R5 is acting as a level 1 and level 2 routes, so it has level 1 adjacency with the R6 and level 2 adjacency with R4, and then finally it is R6 which is part of the ISIS level 1 domain, and it has the neighborship with the R5. And if we talk about the propagation policy on the R3 and R5, so this is the propagation policy which we applied. So if we talk about the route policy, so it's saying that whatever destination match with the /32, then send it to the level 1 routers. Same thing is there on the R5. It's saying that propagate level 2 into level 1. Route policy prop, if destination is equal to /32, then pass, and it's going to propagate into the level 1 routers. So if we talk about the database, So R1 router is learning the LSP from R1, R2 and R3. And if we check about the route, so it has the default route pointing towards the R3 because the attached bit is set by the R3, which is the level 1 and level 2 router, and then R2 is acting as the level 1 routers, and then remaining R3, R4, R5 and R6 are the inter-area routes. So if we check about the database, and let's check the database advertised by the level 1 level 2 routers. So if you can see here, this is the R3, which is acting as the level 1 and level 2 routers. This is the IP extended inter area R4, and it has sent the index value, and this is the re-advertise flag. This is the node sit flag, and this is no PHP flag, and this is for the value because this is the SID index value, it is not the actual value, that's why it is 0, and this is the global, not the local, that's why it is 0. And if we talk about this remaining flag, this is set when the prefix is external, so this is again re-advertise and then node set flag. So same for all. If we talk about the R5, we can see here that index value is R5, and then same flag has been set by the R3 routers. Same for the R6 prefix. And this remaining portion is showing these prefix 7 and 8. We will talk it about later once we enable those, once we redistribute those prefixes into the ISIS domain. So if we check the segment routing label table, and you can see here we are learning the SID value, and based on the sRGB value, that is 1600022399, based on that one it is calculating the label value, and we can say that we have label value for the all the prefixes. So and if we talk about the show MPLS forwarding for all the prefixes, so ELFIP table has been populated. Let's say traceroute to sr-mpls, and let's check the for the destination. So we can see that R1 is pushing 16006, R2 is doing the swapping with the same label, R3 is also swapping with the same label, R4 is swapping with the same label, and for R5 it is implicit null, and finally it reached to the R6. While propagating these routes to either level 1 or to the other area, if we talk about the OSPF, there won't be any behavioral change in perspective of the segment routing. So if we talk about the ISIS, and if we are propagating those routes from level 2 to level 1, so prefix along with its segment routing SID index value will be propagated into the other level or other area, but the adjacency-sid which are local to the routers are not going to be part of those propagation. So as we saw earlier in this output, so let's capture the pcap and see how exactly it looks like. If we can see this capture here, so extended IP reachability TLV is used to propagate these prefixes into the level 1. Let's take for the prefixes R4. If we talk about the flags which we discussed earlier, so this is the re-advertisements flag is set, and this is the node sid, because this is the nodes segment ID which are propagating from the level 2 to level 1 area, and we don't need any PHP scenario here, because this router knows that this router is situated in the other area or other level. Hence the L1 L2 router set the no PHP bit and send it towards the level 1 routers. This is the index value. So for this 4, so index value is 4, and we were talking about the few other flags where if for the external prefixes it will mark it as a 1 here, and this is again same re-advertise and note set. So let's enable the, let's bring up the node R7 and R8 and see how the segment routing reacts for the external prefixes. If we talk about the R4, which is the level 2 router, and if we check the verbose, so you can see the similar output which we saw on the R1, some flags and then sRGB values advertised by each routers. And if we check about the show route ISI, so all the routes are marked as a L2 routes. Show ISI segment routing label table, and you can see that we have learned the set for all the prefixes, and same thing has been pushed to the LFIP table. If we check on the R6, we should see the similar behavior which we saw on the R1. So here R5 is acting as a L1 L1 L2 routers which are set the attached bit here. Let's check the database for the L1 L2 routers and see what he is advertising. So we can see that R1 with the index value 1 and along with the few flags, R2 with the index value 2, R3 with the index value 3, and then sRGB values. if we check the segment routing label table, so we can see that we are learning the prefix-sid for all the routers, and same has been pushed to the L5 table. Now let's bring up the router R7 and R8 and see how the ISIS or segment routing reacts to these external prefixes. So R7 and R8 is up. R7 is running the IP4 BGP eBGP with the R6, and R8 is running the IP4 level unicast with the R5. So let's check their neighborship. It is up, and we are learning the 8 routes 1 2 3 4 5 6 7. Let's check on the R8. So it is IP4 level unicast. Yes, we are learning the 7 prefixes there 1 2 3 4 5 6 7 and its own 8. Let's check the status on the R6. Yes, it is learning the 2 prefixes. Let's check on the R5. Show BGP IP4 label unicast. Yes, we are learning the 1 prefixes, that is 8. Let's check that prefixes because we are advertising the prefix-sid along with that one. So you can see that receive label is 3 because it's directly connected to R5, so it will be the implicit null, but the label index value received from the R8 is 8. So if we check the configuration for R8, show run router BGP, so we are advertising that prefix R8 prefix along with the SID index value. So if we check the route policy, so we are passing that parameter here, and that is advertising along with these prefixes. So we can see that R5 is receiving that label index value. Let's check on the R4. And let's check advertised by R5 verbals. So you can see here we are getting the external prefixes, and as I said earlier that X flags X is marked for the external. So if we see the 6 which is internal, we don't see that X flag is marked because that is the internal prefixes, and for the external flag which we called as the X plus, it will be marked, and for the prefix 8 flag will be marked and along with the index value. So if we check the label table, so it should mark for the R8, that is 16008. Let's check on the R6 which is in the level 1, and let's check the database advertised by the R5. This is 8 here, and R7 is directly connected, so it will be the part of the BGP because it's active in the BGP, hence we don't see those prefixes here, and it is advertised by the R6 not by the R5. So this is the database we are checking for the R5. So here we can see that index value is 8 along with the flag set. Let's check on the R1. Let's check the database which is advertised by R3, LSP which is advertised by R3, and we can see here that R7 is marked with the few of the flags, but there is no index value because R6 and R7 is running the plain IPv4. But if we check about the R8, for R8 we are advertising the SID index value 8, and we can see that those flags has been set by the R3 while advertising or propagating those prefixes into the level 1 area. So if we check about the label table, so we should see that index value for 8, and if we trace route the sr-mpls for the 8 prefix, we should be good, and yes, we are good here. But let's say if we talk about the 7 prefix, so we don't have any label for that one, so it won't work. But if we do the normal trace route, it will work because it's acting as a plain IPv4 traffic. But let's say we have the requirement that R7 traffic is also need the segment routing, or it should go via the, or it should use the segment segment IDs or segment labels. So if any external prefixes which is not part of the ISIS domain and it required the SID value, so in that scenario we need the mapping server in the network. So let's say that R7 prefix is advertised by R6, so let's configure R6 as a mapping server. Then prefix 777 and then index 7 range. Do we need to define it? Range, that should be okay. So we are advertising the index value 7 for the prefix 7, and that's it. So if we talk about the mapping server configuration, so R6 will act as a mapping server, and under the RISIS we need to advertise the prefix-sid mapping. So receive is by default enabled on the all routers, so we just need to advertise it from the mapping server. And if we talk about the mapping server configuration, first we configure the prefix-sid for that prefix, and then we advertise into the ISIS. That's it. So if we check on the R5, the LSP or database advertised by R6, we should see that yes, R7 we are receiving. We will capture that packet and see what are those markings, and then we can see here index value is 7 is advertised by the R6. So if we check the active policy, so we can see yes, we are getting those prefixes. Let's check it on the R4. So let's check the database for the R5. We see that policy is not active here, but let's cross verify on the R5, and indeed we just received the prefix, but there is no SID index value. What does it mean? Because here R6 is acting as a mapping server, and it has advertised to the R5 or to the level 1 domain. But challenge is that R5 is not able to propagate that information into the level 2 domain. Means we need to have the level 1 or level 2 router acting as a mapping server, which is connected to the level 1 as well as to level 2, and it can send the mapping server entry to the both levels. So let's remove the R6 entry. And configure the same stuff on the R5. Pasting the same stuff here. So if we check the configuration, segment routing, mapping server, prefix-sid map, address family, that prefix and its index value, and then I'm advertising those mapping server entries on the R5. If we commit, so on the R6, if we check the active policy, yes, we have that. And if we check the database from the R5, we should get that entry. Yes, R5 is advertising that database entry, and R5 should have it. And let's check on the active policy on the R4. Yes, because now the level 1 level 2 router, which is R5, is acting as a mapping server, and he is able to advertise the mapping server entries to the both levels. So if we check the R5's database, so yes, we are able to see it. And then if we check on the R3, show ISI segment routing prefix-sid map active, yes. So if you check this show ISI segment routing label table, we should see that entry here. And even if we check on the R5 or R4, we should see that entry here as well. So till R3 it is okay, but again here we are facing the same problem while propagating prefix from level 2 domain to the level 1. What the problem, the same problem which we face where we made the R6 as a mapping server. So let's verify the entries on the R1. Segment routing prefix active policy, no. So again same challenge here, so we need to make R3 here as a mapping server. So in our scenario we will have two mapping server, so both L1 L2 routers acting as a mapping server, and it is must if we need the end-to-end reachability for that. So let's configure the R3. So let's configure R3 as a mapping server. Segment routing, mapping server, prefix-sid map, address family, prefix, its index value, and then advertise it under the address family IP for Unicast. Before that, if we verify there is no entry for R7 and there is no active policy. So once we commit, we should see the active policy. Yep. So we can see that we are getting the R7 prefix and its SID index value. So if we check this label table, we got the R7 prefix. and if we trace route is sr-mpls, we should be able to reach using the segment IDs. Here it is. So challenge with this scenario is that we have two L1 and L2 routers, and we need to make both of them as a mapping server if we need the end-to-end reachability. If we check the database for the R3 verbose, here is the 7 entry, and let's check the LSP for that. So advertising the mapping server entry, so ISIS use the SID or label binding TLV, that is separate TLV from the extended IP reachability TLV. Here it will just advertise the prefix and its information, but there won't be any label information here. Separate label information is advertised by SID and label binding TLV. So if you see here, family mirror context, flag is D, and then here we can see the other flags as well, and here we see the SID index value. For the prefix R7. That is the major challenge if we need to advertise the prefixes IP for prefix, and we need the segment ID for that. And if we are using the multi-level, so this is the one of the biggest challenge, that we need the each L1 and L2 router act as a mapping server. That's it for this ISIS multi-level or redistribution segment. Thanks for watching it and hope that you have enjoyed it. Thank you very much.